So just a reminder, this session, like all other sessions, is being recorded and live streamed on YouTube. All right, just to review where we are and what we've got going on for the rest of the day and for the weekend. So currently we are in not 5.e, this should be 9.e, sorry. Copied that over from another slide. So unless we've traveled back in time, this is still day 9. We'll have a little bit of Hackathon lightning talk time, project discussion. We'll have our lunch break from 2 to 2:45 as usual. Again, we'll have our come back from lunch into our breakout sessions. We'll have a short break from 4:15 to 4:30, and then we'll have a sort of workshop wrap-up session, extended Q&A and hackathon prep. What we would like to do at this time this afternoon is to help people get into hackathon groups who have not yet found a group. So we'll have some open time for discussion and for teaming, and try to get as much hackathon prep done this afternoon before tomorrow so that you can kind of hit the ground running as much as possible tomorrow morning. And then we'll still have our regularly scheduled Q&A from 6 to 6:30. People can come and talk about whatever issues or concerns they may have regarding the workshop, or any questions that didn't get answered today in the other modules. Or again, if you have continued hackathon questions, we will be around till 6:30 today to answer those. So just a reminder on our breakout session schedule. Unfortunately, it looks like Giuliano is not going to be able to get back in time to give his presentation today. So we have canceled that session for now. We will be sending out a link to a very similar version of the session that he gave last year. So if anybody was interested in learning how to publish models as NanoHub tools, we will send that link out tonight in the evening summary. And feel free to contact us with any questions you may have about that. If you are interested in publishing on NanoHub, we'd be happy to help you get set up with that. So the remaining 2 sessions today that you have to choose from are again with Derek Mu and Xian Zheng on an interesting CompuCell model that they've been doing. They'll also be demonstrating a very interesting Python script that they developed for generating very pretty 3-factor graphs, basically with the click of a button that you can modify to your own purposes. So anybody interested in that we recommend that you attend that session. And then we also have Gilberto Thomas giving a session on using the Adhesion Flex plugin in CompuCell 3D. So those are the 2 sessions today. And again, we'll send out the link to last year's version of the Publishing Models as NanoHub Tools talk this evening. Again, a reminder that the Derek Mu's session will take place in this room. So if you are attending that session, you do not have to go anywhere. If you would like to attend Gilberto's session, you will have to join his link separately, and that will require a quick registration again. Once we're finished with those, again, we'll come back to the main session here in the first link. So just to review the hackathon schedule, there's been a very slight change here that we'll talk about in a second. Let me fix this formatting error real quick. All right. So again, just to go over the schedule for tomorrow, the Saturday session, we'll take that first hour to finish organizing teams. If anybody still needs help finding a team or finding teammates, we'll have an additional hour tomorrow to get that finalized. From 11 to 1, you'll have your first morning work session. So we recommend using this as your setup and initial model building session. So we talked a little bit over the last week about how obviously you won't have time to go through the entire model building workflow, but we do recommend that you do some version of the early stages of the workflow at the beginning of the hackathon, just so that everybody is on the same page about what it is you're trying to accomplish, both technically and biologically by the end of the weekend. Obviously, if you'd like to go ahead and jump into the code during that session, that's perfectly fine. We will leave that up to each group as to how they want to approach their project, but we do recommend doing, again, some level of scoping of the project within those first couple of hours so that everybody knows what's going on and what they're supposed to be doing. The announcement here is that we will have an extra session tomorrow during the hackathon meeting. So Maciek Swat, one of the lead developers of CompuCell, will be coming to present our session on how to do CompuCell plugins in C++. That'll be taking place from 11 to 12. There'll probably be some extra time for questions there.
I think it'll start at 12.
Oh, it starts at 12? Okay. It must have gotten moved. So let me change that real quick. So this will go from 12 p.m. until, did we have a finish time?
Probably 90 minutes, 1:30.
We'll just say, so it'll go until roughly 1:30 p.m. Maciek will probably be able to stick around for a little bit to answer questions. That will happen in the main session of the hackathon meeting. So each group will still have their own breakout rooms. So if you're not interested in attending the extensions session, you will have breakout rooms where you can go to work in the quiet. So don't worry about that. But we will be having that session occurring in the main meeting for anybody who's interested. Even if you're not planning on attending the hackathon tomorrow, but you would like to attend that session, you're welcome to join us at noon to hear more about CompuCell extensions in C++. And again, those links will go out by email tonight. So returning to the main structure from 1 to 1:30, we'll have an afternoon check-in just to see how each group is doing. We'll kind of do a round robin check-in with each group. You can briefly show what progress you've made and address any questions to us that you may have. Again, this half-hour session is not really to necessarily solve the problems in real time that you're having. It's more for us to get notes on who needs what in the breakout rooms so that we can send people to the rooms as they need them. If you have very quick questions, we can get them addressed. But if you're having significant challenges with your code, we will send people to work with you in the breakout rooms after the check-in. From 1:30 to 5, you'll have a long afternoon work session. And then from 5:30 to 6, we'll have end of day reports. So again, this is more of just a check-in, find out what people need for the next day so that we can be making some preparations overnight for who to send where in the breakouts the next day. James, if somebody is asking specific questions, feel free to break in. I can't see the chat with my current screen share set up. If it's not something that's easily answerable.
Sharon asked, so the idea is that people spend the weekend in Zoom, but mostly in a team breakout room. So we do need team names, although we can set those up also tomorrow morning so that we can create them. And we do need to get a sense of who our support team from our end is going to be, to anybody who, Julio, who can attend to help out. Jim Sluka. But yes, that the idea is that mostly people will be working in breakout rooms. Instructors will circulate between the breakout rooms as available. People can come back to the main session to ask questions if there are people sitting up there.
Yeah, I will be sitting in the main session all weekend, basically, as the host of the main session. So if you have specific questions and you need, so if you're having, the main session is kind of for two things. If you're having issues with logistics and teaming and things like that, you can return to the main session to have those addressed. Or if you need help from somebody who is currently working with another breakout room, you can return to the main session and let me know, and we'll try to get them over to you as soon as possible. So that's kind of the idea, is the main session will just exist for people to come get general help if they need it. But you'll be mostly working in your breakout rooms with your teams. Or if you would like to work alone, we're happy to make a breakout room for you too, if you would like to have some quiet or have a place where an instructor can join you specifically. So if you are working on a project on your own, in the past, we've had people kind of just sit in the main room and work, and then as they have questions, they can ask, and people in the main room who are also working themselves may be able to answer those. So you can kind of have like a sort of a study hall approach, and then we'll have breakout rooms for each person if they do need to go ask a specific question of an instructor. So day 2 on Sunday, we'll start at 10. We'll do a quick check-in just to see if there's been any progress overnight. People tend to work on these things after 6 o'clock. And then you'll have from 10:30 to 2 to work on your models again. We'll do another quick check-in. And then we'll work again from 2:30 to 5. And then we'll have a slightly more formalized hour-long presentation of where people's models ended up by the end of the weekend, what still needs to be done on them, and what kind of help they may want moving forward from the team post-hackathon. So you'll notice, Sharon's asking, all the ones that say work are in the breakout rooms and the others are more formal. Yes, so your work sessions, you're free to move into your breakout rooms. The check-ins will take place in the main meeting. That's a good question, Sharon. Thank you for clarifying that. So yes, all check-ins will take place as a group. And then the work sessions, you're free to join your breakout rooms. Julia's saying, I'll have to work in the morning, we'll join by the afternoon. Is this okay? Yes, it's perfectly fine. We understand that the hackathon schedule is a little bit intensive and people will have to just kind of work when they can. That's normal. It'll be up to you and your team to determine who's going to take what shifts and who's going to be working on what, when, which is another thing. So you'll notice here, there's no scheduled lunch break because of time zone differences and just how people's projects are going. When people will be taking breaks to eat will kind of be up to you and your group. So that'll be up to you to schedule. We'll probably take, so the official like instructor lunch break, because we're all in the same time zone here, will probably take place after Maciek's session at 1:30. We'll probably take half an hour or so people can go grab some food. But lunch breaks for everybody else will be up to each group. So Pete says there would be oral and or written reports at the end. Yes, so it'll just be an oral presentation. We'll have a few slides as a template for people to plug in, basically a report on their progress. But this is not a big formal, it's not an exam. Don't worry about it.
Not an exam. The goal is just to help you think and organize your thoughts, to wrap up and to get the help and you need and to let other people know what you did.
Yeah, basically the oral presentation at the end takes the format of, we like people to spend a couple of minutes explaining very briefly the biological system that they're modeling, because people may not have the context that you're working within. And then we'll have you kind of walk through how the hackathon went for you and your group, present your final model, and then talk about anything that you need. So, it's 10 to 15 minutes at most per group. Again, this is mostly so you can show off what you've gotten done over the weekend, but also for us to know where every group has ended up so that we can give help as needed moving forward. Any other questions before we move on to lightning talks about the hackathon schedule? I should leave that on the screen here for just a minute. Who is interested in giving a quick talk today?
Sharon says she is. Anyone else?
All right. So I have a direct message here from Corinne. Basically, same thing as Julio saying that there's going to be spots where they can't participate fully.
That's fine.
Yeah, please don't worry about that. If you would still like people to be helping you with your project, it is perfectly fine to kind of get set up either through the Slack or at the beginning of the weekend. Let people be working on things. Even if you're a project lead, it's okay if you need to step away for a while. You just want to make sure that the people who are still working on it kind of all agree on who's doing what. So perfectly fine if you can't attend fully. There's no reason to withdraw a project idea just because you're not going to be there the whole time. If your availability is going to be extremely limited, then we would say maybe assign somebody else as the project lead if they're familiar enough with it. But it's perfectly fine just to kind of work periodically on the project as you need to over the course of the weekend. We'll have the meeting open. I think we can leave it open pretty much 24/7. Zoom meetings stale out after 14 hours live. So what we'll probably do is at the end of the workshop, tomorrow. We'll leave it running, and then we'll have somebody close and reopen the group probably at around 10 o'clock or midnight or so. 10 o'clock probably. And then we'll send the link out again in case anybody, gets lost in the process, but we'll have to close and reopen the group so it doesn't shut down at 2 a.m., which is what happened last year.
Right. Well, also, if nobody's doing anything in it, it will disappear after an hour. So in other words, if nobody's logged in or there's no activity in the Zoom, then that will shut down after an hour.
That's true. So yes, if your group is planning on using the Zoom and you come back, in the middle of the night, because again, time zone differences make this sort of interesting. If you come back in the middle of the night and the room is gone, please just shoot one of us an email and we'll try to get it launched again as soon as possible. Please do keep in mind that some of us will be getting some sleep here on the East Coast Saturday night, but we should have somebody available most of the time to relaunch it if we need to.
We can also make team leaders co-hosts for the meeting if needed. And then that way you can keep the meeting going if none of us are here.
Yep. All right, so if there's no other questions about hackathon scheduling, I think we'll go ahead and let Sharon, and did anybody else raise their hand? Who else would like to give a lightning talk or project pitch today? Or just if you have been working on your project on the side here, if anybody would like to give an update on how that's going to potentially recruit new members to the team, then that's also welcome.
I just want to add some thoughts. And this thing was all words and no pictures. So I'm just going to show this. What was, I think, the most interesting slide in this deck was just the things I'm interested in and why I want to do this evolution simulation. And just to repeat, I'm interested in evolutionary developmental biology, the evolution of development and of body plans, and interested in using techniques from artificial life, which is computer science discipline that tries to make biology like adaptive simulations. And I'm interested in their problems which impinge on mine, which is evolution of multicellularity and open-ended evolution. But I've learned from explaining since then to other people what I want to do, that this was a bad explanation, because this distracts from the real essence of what I want to do. So I made another slide. I'm going to share something else. There it is. Okay, so first thing is, when I did that, people, a couple of people suggested things that would be interesting to try to evolve in an evolutionary simulation. And I mean, I have things I'm interested in evolving in a simulation, like specifically multicellularity. But what I really want to get at with this project is something that evolves the way real evolution works. And real evolution doesn't have goals. And so I'm not actually interested in simulating the evolution of X, where X is something you care about and are interested in. I want to model the evolution process itself, which is more open-ended. So evolution, you have living organisms in an environment, and it's a challenge they're presented with. And there's no goal. They just need to survive. They need to reproduce. They need to reproduce. I mean, they don't need to, but natural selection happens because they contribute more to the next generation than some other variant does. And that's how evolution occurs. And that's what I want to happen in my simulation. And so I've put together this slide. I need to get rid of the pictures of all of you. There we go. So I have here a bunch of inputs and outputs, which are, I guess, sort of inputs and outputs from the cell's point of view. I'm thinking of a population of cells living in the simulation. And inputs are sort of all the things that, over here on the left, all the things that impinge on what happens to cells. And the outputs are all the things that they do. And so, and these are general categories and they're not exhaustive. These are sort of examples of the kinds of things in each category. So one kind of input is the universal physics, the things that the cell cannot do anything about, but just has to deal with. Then there's the cell's own internal state, which it knows. Things like target volume and lambda volume, and things like stored energy, because energy is going to be part of the simulation. And then there's things from outside that impinge on the cell, the environment. And that's different from universal physics, because these are just global, where this is stuff that's going on in the simulation and that the cells can react to. And as a result, you're going to get the cells, well, I shouldn't say as a result, because that's not obvious, but the obvious thing is that cells will need to eat and move and grow and divide and secrete and so on. And dying is also going to be an important part of it. If there's going to be natural selection, there has to be the possibility of maybe being successful and maybe not being successful in getting to that next generation. So where the as a result comes in, is that there's an integrator which takes, I only have certain blue lines here for a reason, which takes a bunch of these inputs and makes decisions and gives you these outputs. Now, in real cells, the integrator would be the gene regulatory network and metabolic pathways. In more advanced organisms, it would be even the nervous system, maybe the endocrine system, I don't know. All these kinds of control systems for making decisions. I was thinking in this case, what I want, right? I don't really want to model all the details of all of that, but I want to model that functionality of integrating inputs, making outputs. So one possibility is a neural network or MABOS, which we learned about yesterday. I haven't decided yet whether I can do what I need with it, but I want to look into it a little more. And so, okay, let me leave that there. That's a thing that takes these inputs and makes decisions. There's no arrow from physics, because that's just something that is. That's not really something you're making decisions on. There's really no decision to be made. So, and likewise, these three things in the red are kind of all connected to each other. And there's no arrows to there either, because that's also just something that is. The cell can impinge on how much stored energy it has. That comes from eating. But once it's a condition, it's your current condition. And that combined with the fact that it costs energy to do all these things. And you also have to maintain, there's going to be a gradual ongoing drain because of metabolism. And then dying is not something the cell ever chooses to do, but if you're out of energy, you're out of energy. But all these other things are the inputs and the outputs of the integrator. And then where does evolution come in? Well, the genome should basically be this integrator. It's just an encoding of all the data and topology that's in it, and then mutation act on that, and and then that should hopefully give something interesting. And I think, I had nothing else. But just to say that, so this is a really ambitious thing. This is kind of a long-term goal, and obviously there's lots more things that can go in each of these categories. So for these 2 days, I want to do the most stripped down possible version of this. I do think it's going to need most of these actions here, and it's going to need most of these components really, but the simplest version of each. One thing I have in mind, my sort of pet idea is I want to have food. So there's different ways to do food. You can do a field, like nutrient, like we had in some of our examples, but you could also do solid food with, inanimate a cell type that is food, which sits in the environment. I kind of like, ultimately I want to use both, because I think the more complexity in the environment, the better for evolution. But for a short project, I want to pick one I think I want to go with the solid food because it's more mechanical and might yield more sort of mechanical visual types of behaviors. And I want to try to get predation. I want to try to get cells also be food. So, and I have some ideas about how to do that. So that's sort of my pet biology thing to get going. So I'm going to do the biology first. That's my idea. Is like get some, because until you have some things going on, there's nothing to integrate in an integrator. So yeah, get some cells doing moving around, eating, gathering energy, dividing and so forth, and limited by energy. Get that all going, and then see if I can build a genome and mutation. So that's my plan. So that's really all I wanted to share. If that is a better description that piques anybody's interest.
I think if you eventually want to understand your integrator as a genome, some kind of, for example, pathway or MABOS will translate into a genome eventually. But neural network, although it's very flexible, as we were discussing, it's a black box. So yeah, choosing which integrator you want to use in the model is really the hard part. I really don't know which one I choose. Probably I would go with neural network, but there is this downside. You cannot interpret the neural network in the end.
Well, I'm not sure that's a downside. I mean, yes, it'd be nice to be able to understand everything, but that also might be part of what gives its power, and that might be true with MABOS also if it's doing the interesting work. But yeah, we can talk about that more, and I'll think about that more.
I mean, specifying a genome doesn't give you interpretability either, because the genome doesn't specify the integrator; it specifies the parts in the integrator. And so it's now it's true that there are certain components of the genome, like the regulatory sequences, that have more of a functional structure. But in general, there isn't really any representation of the integration. Integration is a result of the interactions of the components that are specified by the genome. But the genome doesn't specify those components, and it doesn't specify the interactions.
Well, genome is, I mean, as I'm understanding it, both with neural networks or MABOS, it's a topology and strengths of connections.
Okay, so you're talking about the genome as what I would call a model structure.
Okay.
And I thought you were using the word genome actually to mean the genome as in DNA, which is not what I'm thinking, not what you seem to mean. So I misunderstood.
Yeah, I mean an encoding of whatever is in this circle.
Okay,
so
that's
you capture everything about it, right? And then you, by mutating it, whether you're changing the topology or the strengths of, what do they call them in a neural network? The weights.
the weights. Yeah.
What were I think in MABOS, it's probabilities of
Right.
on the edges, right? So
Right.
you're modifying those things. That's your mutation. So you have a different type of processor after the mutation.
And Peter points out that this is exactly, I mean, these evolutionary models are precisely multi-agent reinforcement learning. So absolutely, Peter, that's a good set of references to look at to see how people do.
Yeah, so I don't know a lot about that, but that feels like AI stuff. And there's a lot of crosstalk between the artificial life kinds of simulations and AI. So yeah, for sure. And thanks for the link. I'll take a look at it.
I'm glad to see you developing this concept. I think it's an exciting opportunity.
It's 2 days is a very short time for this, but I should be able to do something that's at least interesting. I don't know if I'll get as far as integrators and actual evolution, but we'll get something. Just getting predation will be fun.
Well, predation and then having some information in the system that the organisms can follow. There has to be some kind of signaling going on, because ultimately one of the things that you have to have is they have to learn how to respond, as you say, to respond to signals. So there has to be a signal in the environment. The problem with a simulation is, since you don't get anything for free, if you don't put the signal in the environment, it's not there. So you have to decide which signals you're going to create.
Right. I was thinking of lower priority for like actual literal explicit signaling by chemicals and so on. But if you can detect any aspect of your environment, that's a signal, whether that's a mechanical signal or whatever. So yes, there has to be information to act on where the integrator has nothing to do.
But please do take a few minutes over lunch, and there'll be some time this afternoon too, if you're planning on being here then for module 4, to go ahead and make sure that you've filled out your information in the hackathon teaming document. Even if you just, had a blast of inspiration last night and now you have a hackathon idea, it's perfectly fine to put it in now. It's not too late. But please do take a minute to go ahead and fill that out so we have as much information as possible so we can make good use of the time in module 4 today.